Exponential models, page 6, number 4. The area A, meters squared, covered by a certain weed is measured at 6 a.m. each day. On June 1st, the area was 50 meters squared. Each day, the area of the weeds grew by the formula 50 times 1.06 to the power of t, where t is the number of days after June 1st. Okay, so June 1st would be day 0, t equals 0, and the area was 50. Day 1 would be 50 times 1.06, for example. Okay, so let's put the formula in the calculator like we usually do when we have a formula. We'll put 50 times 1.06 to the power of t, or we're going to put x in this case. Graph. And we'll look at the table, second table. Oops. It's graphing. Okay, now it's done. Let's see, so day 0, or t equals 0 is 50. T equals 1 is 53. Okay. 53 here. Okay. Sketch the graph for -4 to 20. Oh, that's interesting. They're asking us to do starting 4 days before. So let's see. -4, -3, -2, -1. So let's just scroll up here and see what -4 gives us. -4 would be 39.6. -3 was 41.9, which is the same as 42.0. -2 is 44.5. And -1 is 47.2. Okay, and we're going all the way up to 20. So let's see, 10, 20. What's the value at t equals 10? $89.5. Let's go to t equals 20. 89.5. T equals 20, 160.3. 160. Okay, so we have, let's say, -4. Put 0 here. Put 20 here. 10 here. -4. And let's see, we're going up to 160. So we'll call this 200. And 20, 160 is the highest point, so that would be there. 1089 would be about there. 153 would be about there. And 0, 50 would be right there. And -4, 39.6 would be about there. Okay. So let's draw a line through all that. Okay, about like that. No, that's not very good, but let's try one more time. Kind of like that. Okay, so that's the graph. Explain what the negative values of t represent. Well, remember, June 1st would be day 0, so this would be, like -4 would be 4 days before June 1st, so that would be, the day before June 1st is May 31st. So May 31st, May 30th, 29, 28. So the negative values of t are days before June 1st. Calculate the area covered by the weeds at 6 a.m. on 15th of June. Okay, so 15th of June, Which day would that be? Well, June 1st is 0. So June 15th would be, I think, day 14. So let's go down to 14. Actually, we have 14 on the screen already. It's 113.05, so it's 113. So June 5th would be 113. 113 meters squared. Find the value of t when the area is 80 meters squared. Okay, so this is saying when a is 80, what's the value of t? So let's try to find the y value of 80. There, it's pretty close, 79.69. So we'll say it's 8, right? Okay, so that would be 8 days. 8 days after June 1st, so that would be June 9th, actually. Okay? All right. That's number 4. Now we're going to go down to number 5. Let's clear this. Okay, the graph shows a function k times 2 to the x plus c. Find the values of c and k. Now remember, this c value here is like asymptote value. So we can see that the asymptote here is -10, right? Y equals -10, because that's what it's getting close to. Okay, so we can already see that our c value is going to be -10. And then we need to find the value for k. Let's see. If we know that c is -10 already, let's try to find it using the point x equals 0. So let's see. Like at x equals 0, we would have k plus c here. And k plus c is equal to k minus 10. And it looks like at t, or at x equals 0, we're at about -5. -5. So that means k minus 10 is equal to -5. So that means k is equal to, we'll add 10 to both sides, and that'll give us plus 5. So k is equal to +5. Okay? So I think that's it, but let's just make sure by trying, one extra value. Okay, so we think it's this. Let's see if another value works. For example, a really easy one is x equals 1. X equals 1 looks like it's going to be exactly y equals 0. So let's try that. Let's put 1 in. We'll get that, and then we'll have 5 times 2, which is 10, minus 10 is 0. So it worked. So yeah, I think our value of k of 5 and our value of c, which is -10, work.